So this lesson is going to discuss conditional probability. This can get a little complicated. In particular, it gets way complicated when you try to use the formula for conditional probability, which is fine, you can. It's just not great. In fact, this particular worksheet right here, there's a typo. This is supposed to be an A here. But basically, this whole thing is all messed up. So we're not going to even use the formula. I'm going to show you probably in class what it looks like to use the formula, and I'm going to show you how like a human would interpret this question, and then I think you'll be fine. So the probability is still the same formula. It's probability of successes over the total number of acceptable trials, but in this particular case, we're assuming that a certain condition occurs. So this question, what is the probability that the spinner will land on 7, so there's your success, given that Naomi has spun a number greater than 5? So somehow we know that Naomi's going to spin something bigger than 5, so she's either going to land on a 6, a 7, or an 8. So there are only 3 total possible outcomes. Now, out of these 3 outcomes, landing on a 7 is 1 out of the 3. That's our answer, 1 out of 3. So again, there's a typo on here. It's a hot mess. The formula is not helpful. No one likes to use the formula, okay? So whenever they say given, the given is the part of the problem that is the denominator. So if you want to write down a formula for yourself, put the word given down here in the denominator, and then number of successes up here. So in this question, this is a standard deck of playing cards. Remember, a 52 card deck. And the question is probability that we draw a heart given that an ace is drawn. So in the denominator, you have to ask yourself, okay, if I know I'm going to draw an ace, how many of them are there? Well, there are 4 aces in the deck. And then knowing that I draw an ace, what's the probability that it's a heart? So there's the ace of each suit, right? Ace of hearts, clubs, diamonds, and spades. So 1 out of those 4 is the ace of hearts. I know, it seems like too easy, right? This is where everyone gets really skeptical of me. They're like, oh, Bruzo, you're going to do that thing where you give us easy questions and then all of a sudden it gets really, really hard. No, not today, guys. Given that you draw a club, so in the denominator, you have to ask yourself how many clubs are there in the deck of cards, and there should be 13, right? Because in each suit there's 13 cards. So I'm only looking at clubs. How many of those are the 6 of clubs? That would be 1. 1 out of 13. Alright, the card is a spade, given that a black card is drawn. So again, given that part, that's my denominator. So how many black cards are there? There are 26, right? But out of all those black cards, how many of them are spades? Switch of color here. There are 13 spades. So 1/2. Y'all still want to reduce like we always do in probability. Alright, this one. What I'm going to do is I'm going to draw out the sample space because it's just a 6-sided die. So you're either going to roll a 1, or a 2, or a 3, or a 4, or a 5, or a 6. So the probability that a 4 is rolled, given that you roll an even. So we are either going to roll a 2, or a 4, or a 6, because it says you're going to roll an even. So there's 3 outcomes that are possible. Out of these 3 outcomes, how many of them is the number 4? Well, that would be 1 out of the 3. This question, given that you roll a number less than 6. So I know for a fact somehow that I'm going to roll one of these numbers. So 5 outcomes possible. The probability that it's a 2, well, that would be this 1 out of 5. And then the probability that you roll an even number, given that you roll a 3 or a 4. So somehow I know I'm going to definitely roll a 3 or a 4. So there's only 2 outcomes that are possible. Given these 2 outcomes, an even number would just be this guy. So 1 out of the 2. I don't know if that's the best way to explain it, guys. I really think it is. And again, I think there's a typo here. I don't know. There may or may not be a typo. I feel like something's wrong with the addition of the numbers or something. Just forget this formula. I'm not kidding you guys. It is just a stupid, stupid formula to use on questions where you have charts. This is called a contingency table, and these really help with conditional probabilities because you can like zone in on your data. The question is, find the probability that a student plays lacrosse, given that a student is a junior. So what we're going to do in our class is we're going to take highlighters, and we're going to highlight the information that is from the given part of the problem. So given that your student is a junior, it means you're only allowed to look at the juniors for data. So in this data, the probability that the student plays lacrosse is 34 out of 544, which according to this comes out to 1/6, but again, I don't know if that's true or not, so I'm not really sure if that reduces. I feel like there was a typo and I don't know if I ever fixed it, so sorry. Alright, weddings. We got weddings, attendance, yada yada, what family they're from. What's the probability that a person will attend the wedding given that the person is from the bride's family? So we're only allowed to look at data from the bride's family. So that they are going to attend the wedding, that's the 104 out of, now I really wish they totaled this for me, but I can add, I guess, 136. And again, I don't know. I don't have a calculator handy, so I'm not sure how that reduces, but I know it does reduce. So to whatever it does reduce, that's our answer. Alright, and then baseball. Find the probability that a student plays baseball given, so here's the given part, that the student is a senior. You are only allowed to look at the senior data, so this row. And again, I kind of wish they gave me the total here, but I guess I can add 340, right? 340. So the probability that the student plays baseball is 34 out of 340. Oh, I can reduce that one. That's 1/10. Go me. Alright. So I really like conditional probability because I think it helps when you highlight the chart. If they give you a chart, it's like way awesome. Alright, this question is a shopper who is going to various stores and paying with various methods. So what's the probability that a shopper uses a credit card given that the person is at Jacob's Guess? So given that we're only looking here. Oh, I'm going to get a calculator out, guys. I don't know what these are. Oh, yeah. Alright, so I'm totaling up all the numbers from Jacob's Guess. And it's 1,140. So that's going to be our denominator. So within this data, what's the probability that they use a credit card? So that's these dudes. I'm sure that reduces, so. Oh yeah, nice, 2/5. Okay, next question. A shopper uses a debit card given that they're at Pet Town. So this time we're only allowed to look at Pet Town, which I still need to total. Oh boy, I'm pressing the wrong button. 49 plus 70 plus 28. 147. So, out of those 147 people, how many are using a debit card? That would be the 28. I don't really know if that reduces, but we'll find out. I don't think so. Oh, it does. 4 over 21. And then, be careful on this one, it's given that a shopper is paying cash. So I'm going to erase all my highlighting, which I know you can't really do when you're in your notes, so I apologize. But it's given that they're paying cash, so we're only allowed to look here at all the people who paid cash. So I'm going to total those up real quick. That's a total of 595. So probability that it's TJ, at TJ's, 102 over 595, which I don't think that reduces, but might as well check. I got a calculator. Oh, it does. See? 6 over 35. Very good. That's the end of the lesson. So I have a very uplifting worksheet coming up that we're going to probably work through together. It's about the Titanic and how many people died and what's the probability of you living or dying based on what class you were in. So, like I said, very uplifting conditional probability worksheet. Look forward to that. All right, good luck.